I'm a big fan of using patterns at all levels of maths learning. So I'm just going to quickly look at some patterns which are useful at higher levels of learning maths. Let's fill this in. I'd say you can fill it in your own time, but probably you can do this already. By the way, even at the lowest levels, if I'm doing times table, I include 0 and I generally include minus numbers unless the student is really struggling with them. Because, why not? And then it just makes everything much easier later on. Anyway, whole point of this is, oh look, we kind of knew that 1 times 1 was 1. And this is kind of a proof that minus 1 times 1 is 1. Sort of. It's kind of an intuitive proof, which some people really struggle with, so I think it's good to do it. Now we've got an intuitive proof of what is minus 1 times minus 1. Because a lot of students say, well, wait a sec. How do we even know that that's 1? You're just telling me it's 1. And I'm like, well, look at this pattern. I think we can agree, for example, that 3 times minus 1 is minus 3. Because we're kind of used to the idea that minuses make something negative if you times it by minus 1. Anyway, but then if we just do this pattern and we go from 3 to 2 to 1 to 0 to minus 1, well, guess what? This number here just keeps decreasing by 1 each. Well, sorry, increasing by 1 each time, which means it ends up at 1. And you might think about it your own way, but I think that's a really nice intuitive proof. I'm kind of saying that in inverted commas. Intuitive proof that minus 1 times minus 1 is 1. Yep, so just to conclude, we've done some kind of intuitive proofs to prove this. And a lot of my students thank me when I go through those little things because they say, oh, it makes a lot more sense now. I kind of can accept it a bit more. Okay, let's look at another number pattern. I'm just going to write down all the answers. I've put a blue box around the bit that I think is, well, it's useful and it's kind of why I'm doing this. This can be problematic, this section. Some students will find it very awkward to get their head around when you're adding negative and positive numbers that are very close to 0, as in the answer's close to 0. So there's a bit of help with your intuition maybe. Pause the video and have a look at it if you like. Try and make up your own. I like this one. What's 3 times 4 times 0? Well, it's definitely 0. Because anything times 0 is 0. Because what's 10 times 0? Well, it's just 0 because you haven't got any 10s, yeah? But a lot of students get confused by this one. So let's use a number pattern to get a bit more confident in it. What's 3 times 4? That's 12. Times 1, that's still 12. What's 3 times 4? That's 12. Times 2, that's 24. And similarly, 36 and so on. Oh look, the number pattern strikes again. Suddenly, that 0 there, a lot of my students again, I'm going to keep saying this because this is what I've found is helpful. A pattern like this can kind of break through that barrier of intuition because you think, but it doesn't make sense that it equals 0. And then you see the pattern and you go, oh, it does make sense now. I've changed slightly how my brain thinks about maths, and hopefully maths will be a bit easier from now on. Okay? And in fact, look, there we go. Same example again. We don't need to do that again. I did it on the earlier frame. Okay, finally, I quite like this as another little example. Suppose you're solving this. So just ignore this for a moment. Solve 10x minus 3 equals 12. You may know lots of ways of solving this. But what if you had to use trial and error? What if x is 2? Well, then that would make 20 minus 7. Minus 3, which is 17. That's not right. What if x is 1? Then that would be 20. No, it wouldn't. I'm going mad. 10 minus 3, which is 7. Well, that doesn't work, does it? Wait, it's got to be somewhere in the middle. So what if it's x equals 1.5? So that'd be 15 minus 3, which is 12. Aha! Done it. X equals 1.5. Warning, we just used trial and error to solve an equation. Shouldn't really be doing that. Well, generally not. So why did I just do it? Because I think it's an interesting pattern, and for some students this can be quite helpful. I'd say this is after the earlier ones we did, this is probably the next most common trial and error example that I drop in to help students with their intuition. Thanks for watching. Hopefully that was helpful.